Okay, hello everybody. My name is Xavier Gilbert. I'm from North Carolina A&T. I'm working with the YQI, or I have been for the summer. My project is creating a interface for quantum measurements. Before I start, I'd like to say thanks to my mentor Nishaad back there. He's been very helpful with this whole project, and also Rob, Chow, and Billy. They helped me come up with the idea for this. So why do we need this extension? Well, there are a lot of difficulties involved in quantum measurement, especially because a lot of these devices that we're working on have been built fairly recently. So they can work unpredictably or sometimes not how we would expect them to. In a case like this, it becomes even more important to be able to quickly visualize your data to make sure it's matching up how you would expect it to. So to solve this, I devised a VS Code extension to help visualize and interact with the quantum device measurement data that we have. Just for a little bit of background, this is, may have heard Michael mention these fridges. This is a picture of one of them. What these fridges do is they cool down qubits and our cavities to extremely low temperatures. And we need these temperatures to do our measurement. So just so you can have a visual of what that might look like. Now, this is an example of one of the measurements that the extension would interact with. This is a ring down measurement. And what this is, it's a way to measure the quality factors of our cavities. These cavities have a quality factor. And what this graph shows is, or what I start with is, energy is pushed into these cavities, and some of the energy is absorbed by it while the rest is reflected. This graph shows the energy that has been reflected back off of the cavity. So if I can just demonstrate how this works to you, you may notice this big spike right here. What this is when we first start driving the energy, all of it is reflected off. So as soon as we start, boom, none of it is absorbed by the cavity, but over time through this curve, the cavity starts absorbing more of the energy. So that's why it starts to balance out. The cavity takes what it likes, and whatever it doesn't like, it just sends back at us. And then once we get here, this is where the drive is turned off. Once the drive is turned off, this dip right here is the energy left in the cavity. It begins to decay. So what is the actual extension? As I said, the extension is designed in Visual Studio Code, or VS Code, and it is designed to visualize the data we collected from our measurements. It displays plots of our measurements, and the user can click on these plots. And when you click on a plot, it opens the data that corresponds to that measurement that you've done. So before I show you a little bit how it works, just some technical details about the making of this extension. So I used 3 coding languages to create this. I've been asked before, why do we need 3 different coding languages to make one extension? Well, TypeScript is needed to actually make the backbone of the extension. If you ever want to make an extension to VS Code, you need to have some knowledge of TypeScript and or JavaScript. Python, many of our scripts that we use to actually process data are created in Python. And HTML is simply made to actually display our plots in what we call a web view. A web view is a part of the VS Code API, and the VS Code API provides a set of tools for building extensions, including some commands and these web views I talked about. So this is what the actual extension will look like. So this environment is VS Code, just in case you haven't seen it. To start, you click the command palette at the very top, and you type in this command, YQI plot, open window. I renamed it to open image window. But once you do that, you will be prompted to select a directory. This parent directory houses all of your data, right? So each of these folders contains a image, a plot image, and also some data corresponding to that. What the extension does is it automatically goes through each of these, it pulls out the images, and it links the data in the folder to it. Before, if you wanted to look at the image and look at the data, you would obviously have to go through each of these individually, click on this one, look at this plot, is this what I want? No, it isn't. Maybe click on this one, is this plot what I want? No. But all of them are just automatically displayed for you. Each of these images corresponds to each of those folders. And each of these images also has some data linked to it. So once you click on an image, this image detail window is opened. All this is a window that enlarges the picture of the image so that you can see it better, because all we show here are little PNGs of the image. And it displays some of the data in the JSON file associated with that image. So for example, this one only has a time when it was taken and a total iterations value. So once you have decided to activate your runtime, this Python interactive window is open. What this window is, this is how we would start working with our actual data. So the first thing that happens is this variable is made. What the variable is, it's the extension, is the path to the folder containing your data. The reason we need this is the measurements that we need, they take the directory as an argument. The next thing that happens is we import two modules that are essential to how we process this data, this runtime and this ring down. And if you remember, the ring down was the name of that measurement I showed you a couple slides before. And then, as I said, we instantiate a class using these modules, ring down runtime, and we load them using the name of the directory. So what are some future directions and features? I think the beautiful part about this extension is even though we got it what we wanted it to do, there's still so much more that it can actually do. Like, to me, this is like the very beginning of what it could do. This is like just the base version. So the first thing I would want to work on is added customizability. Yeah. So right now, I can go back. The way this is displayed is kind of set in stone. This is how I set up the HTML code to make it look. But maybe everybody wouldn't want it to look like this. So it'd be possible to add, make it so that the user can customize how this would look, and maybe even add some accessibility features, high contrast, things of that nature. Maybe make these are titles of the folders of the graphs, and they kind of talk about what the measurements are. Maybe make these bigger for users if needed. There's this feature that I wanted to add called, I call it the adaptive analysis dropdown. I made the name sound fancier than what it is, but this is an example of what it would be. This kind of like a pseudo prototype. What would happen is the extension would automatically look into a folder containing different scripts. So for example, a ring down, we have ringdown.py, runtime.py, and 3-point-method.py. So what this feature would do is it would automatically read through this file and make this drop-down menu for you to select which analysis you want to do. So right now, we only have the runtime analysis that is instantiated, but obviously not everyone is going to want to do that. We have all sorts of experiments. People are going to want to do different kinds of analyses. So what this does is it makes it so that I don't have to hard code in the analysis, because if you do that, then it's less flexible. And what we want is this to be flexible so more people can use it. So that's why it's called adaptive, because it would adapt to whatever scripts you need to run. Interactive graphs would be another thing I want to add. Right now in this image detail window, this graph is just a PNG. But what if you wanted to, I don't know, zoom into this graph or maybe see the points along here? The next thing to do would be to make so that this graph is actually fully interactable. Some quality of life upgrades, those never hurt anybody. Some keyboard shortcuts. That's definitely just easier to do things with. And expanded use cases would be the final thing. Right now, this is very specific for what we do, but this could easily be expanded so that anyone can use it, right? If anyone wanted to had a bunch of data folders and they wanted to use it, then why can't we make so that anybody can use it? Like I said, right now, this is very tailored to our case, more so the second half of it where it starts doing the analysis, but the data viewing part of it could be, anyone can use it. So that would be the next thing I would like to do with that. And with that, I'd like to say thank you.
Any question?
So you mentioned your software can be used to expand to all types of users. So if we have a different data type, for example, do we need to change the TypeScript you have written, like underneath the hood?
So as of now, what the extension does is it looks for a JSON file in these folders it's looking at. That of now would need to be changed, but I'm working on making it even more flexible. A big thing I kept thinking about when making this is flexibility. So right now, there are a few things hard-coded into the folders that are needed. This extension looks for a file called metadata. And it looks for another file called keywords. But right now, those are hard-coded in. So if you were to try to run this extension now, which it is on the extension store as of now, but for many of you, it wouldn't exactly work how we want it to because it's still tailored to us. But in the future, I would add some settings that could automatically change so that they wouldn't need to have to go into the code themselves and add these features. But I'm working on making it more and more flexible as I go on.
Thank you so